Right, my name is Stephen Cannon, and this is a presentation on doing a first trip analysis test on a substation circuit breaker for English 314. So the first question we have is, why do a first trip analysis? Well, what a first trip analysis accomplishes, it performs a timing test on a breaker. For those who may not be familiar with breakers are large equipment that interrupts power that's flowing to the substation. They're anywhere from 7,000 volts all the way up to 230,000 volts. And whenever a fault hits the line, a breaker has to open and isolate the fault and cut the power off. And so this is a test that will measure the timing of that breaker to make sure that it's opening fast enough to perform its duties without damaging other sensitive equipment in the substation. So the benefit of doing a first trip analysis is it analyzes a breaker in the in-field condition. Most of the tests that we do on breakers, they have you have to take the breakers out of the service, which means you have to operate them, open them, you have to open up switches on each side of the breaker, isolate them, and then you're able to start your tests. These you're able to do it while it is live, and you get a real-time analysis of how the breaker will perform with this test. So looking at the advantages of capturing your first trip and using this device, and this is a newer technology device, is first off, like I stated, the breakers can be tested in energized state. They're energized, they could be tested energized, and you're able to test the lubrication of this breaker when you could test its first trip or its first operation. And a lot of times these breakers will sit 2 or 3 years without an operation, and you want to test the bearings and the lubrication, and this allows you to do it. Secondly, this test can be performed in about 10 minutes. It's a real quick test, and it gives you kind of a quick and dirty look at the breaker, and it helps you determine if you need to do other tests to determine its condition. And third, this device allows you to overlay different operations so that you can analyze the speed that it's opening 2 years ago compared to it opening today. So your connections, you have this profile P2 analyzer, and then your leads come out. You'll have to hook up to the breaker on, you have 2 leads going to the DC, one to the positive, one to the negative, and then you'll have, and then what that represents on this picture, a red line and a black line going to your DC. And then you have your blue line, which is your amp probe, and that's going to monitor the current as it goes to your coils. Your coils is what operates the breaker and allows it to release its energy into open or release its energy to close. Trip coil, obviously it trips it open. Close coil closes the breaker. And then the green wire goes to your CTs, and those are your CTs on the line, so you can tell when all 3 phases actually do open to make sure that your timing is correct in the breaker. So the example we have here that we're going to do is a Westinghouse breaker. This is an oil breaker. It has an air pneumatic operating system. This is actually at Chigacha Electric and breaker 1616 at the International substation. It's a 138,000 volt breaker. So first thing when you're going to do this test, you have to look at your DC prints, and you got to determine where you're going to put your leads because every breaker is different. So first we're going to look at where our main DC source is, because that's the first leads we're going to hook up on the device. We got to be able to separate your negative and your positive nodes. Then next we got to find where our trip coil is going to be, because that's we have to isolate that wire that's going to go to the trip coil so we can monitor the current that goes through it. So you need to find that, and then obviously after it's open, we're going to have to monitor the close. So we're going to have to find the close coil and then isolate that wire that goes to close coil so we monitor the current on it as well. So once we go to our prints and we understand that, we'll go to the cabinet of the breaker, and that's what this here is. And using our electrical prints corresponding with the physical layout, we're able to tell where our DC lines are. So this is where we would hook up our DC leads to the test. Our amp probe will be over here because these are the leads going to both the trip coil and the closed coil. And then our CT leads will be connected here. And what this test does, and the reason we're monitoring the current, is because this is going to record the current going through the coil as on a time basis, and that coil will be energized. That coil will be energized. It'll release a latch that operates the breaker, and then once the breaker is fully open, it mechanically cuts the power off to the coil. So by seeing when that power is cut off from the coil, we can tell in milliseconds how long it took the breaker to actually operate. All these should open within 4 to 5 milliseconds.
Stephen Cannon with Chigach Electric. We're here at International Substation with a Westinghouse AA10 breaker, and we're going to catch the first trip using the Kelvatech profile tube. And this is a energized breaker, and it is in the closed position, so we're going to catch a trip. So before you start to catch a trip on a breaker, you probably need to go through the prints and verify where your wires lead to your closed coil, where your wires lead to your trip coil, and then which CTs are being in use, so you can use them on your trip. Now, first thing we got to do is our DC supply, your positive and negative. So we verified here on our control that the negative is on the bottom. So there's our negative lead, here's our positive lead. Then we got to put our amp probe on, and our amp probe should be turned on to 20 amps. And this has to go on the wire that's going to lead to our trip coil. So when you're catching a trip, you'll put this on the wire that leads to your trip coil. If you're catching a close, this will be on the wire that goes to your close coil, and it has to be in series because you need to monitor all the current. So we've already looked at the prints, and the wire that goes to the trip coil is in between this switch and this fuse. The easiest way to get to it is on the back side. So we've turned our current probe on, and we've connected to the wire that leads to our trip coil. So next we're going to put on our CTs. And the prints have verified that 1Y, 3Y, and 5Y, the CTs we're going to monitor. Okay, so now it's hooked up. Now your amp probe has to be on the wire that leads to your coil, but you can't put this too close to your coil because it reads a magnetic field. And since your coil is producing a magnetic field, it can mess up your readings. So now we have everything hooked up. We've turned on the profile. We'll go to test. You have to enter the information, enter your substation, your breaker type, your breaker ID. I've entered this in. You entered it like you would text on a cell phone. And this is International Sub. This is a Westinghouse AA10 breaker. Breaker's number 1616. And we're going to perform a trip. So everything's connected, turned on, hit OK. Now our profile is armed, and we'll get the clear contact dispatch, have them trip it open and report it. Alright, so we've caught a trip, successful trip here on 1616. We have the CTs, and it looks like a good graph. After you catch a trip, be sure to keep hitting OK until it says to save, or it won't save and it'll get aggravating. Okay, so we've saved this. We've saved this test. Next you would do is you keep your DC supply on the same, but you'll move your amp probe to the line that will go to your close coil, and you'll catch a close on it, and then you'll want to move this back and catch another trip, and usually want 2 or 3 trips and 2 or 3 closes so you can overlay them and make a true lubrication.